So the next person I get to introduce today is a Dr. Rob Adams. He's an advanced propulsion technologist at NASA. Throughout his 2-decade career at NASA, Dr. Adams led several high-profile projects and studies with a number of NASA centers, government organizations, industry groups, and also academia. His PhD is in mechanical engineering and it's from the University of Alabama in Huntsville. Dr. Adams is also the founder and CEO of Paratus Systems, which develops mobile spacecraft simulators for fun and education. Dr. Adams, welcome, and also War Eagle.
Well, thank you very much. Of course, I went to UAB and UAH, so I'll have to respond with a good Go Blazers. But one of the folks at Auburn was on my committee, so I got a fondness for Auburn anyways. So today I'm going to talk about the Oracle's program. So Space Futures Workshop, the Air Force Space Command at the time, now part of the Space Force, hosted this Space Futures Workshop several years ago. Had 100 people there, and basically they were exploring, what can we expect over the next 40 years in terms of space. They came up with 8 different possible outcomes, everything from a Star Trek utopian type of environment where the United States and its allies were the dominant players in both population, economy, and influence in the space domain, and that the space domain was maintained as free and open for everybody, kind of like how the U.S. Navy, consistently maintains free and open access to the waters today. And of course, there were, more negative outcomes where space was not free and open access for everybody, and that it had, major repercussions on the U.S. economy and whatnot. And so those are some of the less happy options here. So I was at a conference where Joel Moser, the chief scientist for the Space Force, presented this, and I got pretty excited about it. He and I sat down and talked about building a model to look for those inflection points. What are the decisions that need to be made now to ensure that we have the Star Trek future and not the dark skies future? And so that was about 1.5 years ago, and off and on we've been working on this new project. So we set ourselves the goal that we were going to be able to estimate the political and the social, economic, technological, military futures, consequences based on the decisions that we were making in terms of what technological research we're going into, governmental policies, missions, and infrastructure development. And then we were going to create this overreaching program that was going to go through all of the different options and use probabilistic methods to look for those inflection points, those decisions that we can make that's going to give us the best outcomes. And we were going to design this in such a way that we could, it would be a total constant improvement process where we would constantly have subject matter experts bringing in new options to be evaluated against the existing database to see, hey, have we come up with something new here that has promise? So as you can imagine, this is a pretty far-reaching and ambitious project here. We sat down last September and started developing the front end of the program. So basically the user interface, so that we could define what inputs we were looking for and define what outputs we were going to measure against. And so, of course, if we sat down and started writing code, we had to come up with a name for the project. And so my team of interns, having worked at NASA now, knew that we had to have a kick-ass acronym. So this is what we came up with. optimized rational algorithm for conjecture of long-term exploration of space. So oracles. So it's a mouthful, but I'm pretty happy with it. So what I'm going to do right now is I'm going to show you guys a little bit at the end what this program looks like from the front end. But what we haven't done yet is built the back end. And so what I'm saying here is the program as it exists right now is this big, beautiful castle. And if you walk around to the back side, it's a big piece of cardboard with a wooden strut holding it up. There's no code behind doing any calculations. That's what we're working on right now. And the reason we did it that way is we wanted to go out to the community and say, hey, are we asking for the right inputs? Are we measuring the right outputs? You know, we want this to be something where, you know, we're constantly going out to the community and getting feedback. And so, you know, I'm really excited to be talking today because I'm hoping that I'll get a lot of comments and questions and thoughts that will help us develop this. Okay, so the first thing that we needed to do is define how we were going to measure population, economy, and influence, those three categories that the Space Futures Workshop came from. And there's a lot to cover here, so I won't go into too much detail. Population was the easiest to quantify. We're just going to track how many people who are permanently or long-term living in space. So we're not looking at missions. So if we go land on Mars and turn around and bring those guys right back and there's no infrastructure in place, then we don't count them. But we do count the folks at ISS because they're there, permanently, or somebody is there permanently. Economy is really the most complicated and kind of the one that's most out of my bailiwick, actually. So, my degrees are in engineering. So learning about economy has been very interesting and a lot of fun, but I'll certainly admit that I'm a neophyte there. That's a highly complex calculation there, and there's a lot of data, but we know it's incomplete. So later on, I'll show you all the master's theses topics that we've anticipated we're going to be, firing off to get this going. However, to quantify economy, we're going right now. We're looking at the total gross domestic product that's space related, and that gives us an idea of how strong a particular country's influence or economy is space related. And then the purchasing power parity per capita tells us that's space related, tells us how much space is improving the lives of the individual citizens inside that country. And then just tracking imports and exports that are space related lets us know how the different players are interacting with one another. And then finally, influence. And so we sat down and scratched our head, how do we measure influence? We decided we were going to break it into soft influence and hard influence. And soft influence is basically how is everybody outside of your country impressed with you based on your space activities. And hard is, your ability to defend your assets and project force to areas where other people's assets are. So we sat down and started thinking about what we wanted in terms of, or what we would need to track to figure out these different parameters and whatnot. So we came up with the idea that we were going to track policies, technologies, infrastructure, and missions. And noting that, the technologies feed what available infrastructure is there. And the policies also decide, how easy or hard it is to build infrastructure. And then, of course, as Tim pointed out, infrastructure is this huge block here because it's not the sexy part, but it's the part that, gets the job done. And of course, the infrastructure enables the missions, and infrastructure and missions feed into the population, economy, and influence. And really, the missions really just kind of, as we're describing them, really just impact soft influence or hard influence. So going from there, we started breaking down what we were talking about in terms of different types of infrastructure or different infrastructure capabilities. And so, this is a constant influx. And so I'm more than happy for anybody to throw rocks at any of this. But Frankly, I was finishing this part up last night. So, and we broke this down into, infrastructure's ability to provide habitation, to produce products and services, the launch capability to get from the ground to low Earth orbit, the ability to move things around once you've achieved low Earth orbit in the in-space vehicles, the ability to both communicate, bandwidth and sensing, and then there is just kind of a general military capability as well. Now, over here on the left, you'll see that I've broken technologies down into a bunch of different categories, and I won't go through each one of those. But this follows the 2020 NASA technology taxonomy. And so, basically, the Office of the Chief Technologist has broken down anything that we would want to develop in technologies into these 20 different groups. And then I just tacked on at the end military-specific technologies that as the Space Force grows and develops, there's going to be things, the beamed lasers and the ray guns and whatnot that we're going to have to develop that NASA doesn't have a great, interest in, but the Space Force will. Okay, so now this becomes a bit of an eye chart, right? So now we're trying to break down those high-level quantifiable measures that feed into these different infrastructure capabilities and how those are going to flow into population, economy, and influence. And so I didn't do this, but you can imagine the policies and the technologies flowing into the first buttons, if you will, in the infrastructure categories, saying, hey, if I develop this propulsion system, this is what it's going to do to improve my in-space vehicle production tempo or R&D cost, or if I produce this new ECLS system, this is what's going to change the ECLS recycling factor, so on and so forth. So at this point, what we would do is if somebody, a subject matter expert came to us and said, you've got to include my concept into your thing, whether that be a new technology or that be a new piece of infrastructure or a new mission, then we can kind of pull this up and say, okay, well, how are you changing these top level factors, and how is that, and then we can integrate that into the program and let that flow down to see what that's going to change in terms of population, economy, and influence. Okay, so what I would love to do is spend a couple hours going through this in detail and getting lots of comments, but I won't bore you guys. Having said that, I'm very interested in talking to anybody who wants to dig into this with us. So here is the, I'm going to go through a few screenshots of oracles now. All of this was developed in the Unity game engine, so we have a lot of power to do really cool, graphics and whatnot. And not because we want to make a game, but because we're trying to visualize some very complex information. And frankly, if you go look at a lot of the more complex games, the 4X games and whatnot, they've done a lot in visualizing information because they had, an economic motive to do so. And so we've tried to learn from all that. It doesn't hurt that everybody who's writing code with me is a gamer, like I am. Here we're visualizing the solar system. The idea here is that you would, during the simulation, you would be cycling through every year, making budgetary decisions, and then seeing how that was going to affect the decisions you've made in terms of your budget that you're assigning to develop particular technologies, building infrastructure, doing missions, and setting policies. We envision 3 different modes when we use the program. One is the aforementioned, hey, we're going to allow subject matter experts to just input options and whatnot. And so we have basically the ability to input into the database. And then we have 2 options that are represented here. One is where we could run a simulation with humans in the loop, making decisions for particular entities, players in the game. And so you can see a lot of the different space agencies and major companies and whatnot listed here. And then we can also assign AI to each one of those, or at least we expect to once we build the back end. Remember, we still have just this cardboard front here. And we can assign to those AI, basically, their strategy would be what part of the population economy and influence they're most going for. So if they're visionary like SpaceX, they may be going for soft influence. They may be going for the big, cool missions more than anything else. If they're, the Space Force, they're obviously going to be more of a defensive posture, so on and so forth. With that said, so we can run in this mode where we have humans and AI operating together, and then eventually, after we've put on all the data, we've tested the data, we've tested it with humans and whatnot, then we would go all AI and let the AI run through every perturbation and look for those influence points that we could then report up to the top level management at the Space Force, at NASA, even Congress, and say, hey, here's what we're seeing is the big inflection point, the thing where you really need to go after to make sure that the U.S. grows quickly and efficiently in space. So we want to be able to visualize all the things that are going on in space as we go through the simulation. So we've set up the ability to do a lot of orbits and whatnot, be able to zoom in and out on the solar system, even to the point where we can indicate by various different entities, what asset, what piece of infrastructure is sitting there in space or on the ground, and indicate each one of them by their particular logo and whatnot. When we have the subject matter experts come talk to us, we're having them, or when we start doing that, we haven't done that yet, we would have them give us a great deal of information on whatever piece that they're suggesting. Here, we're using the example of a solar thermal orbital transfer vehicle. And so we would collect a lot of information from the SMEs about their expectations and how it changes these capabilities that we were talking about, infrastructure capabilities, where this asset would be located, costs and timelines for development of first, second, and third units, and the expectations on potential outcomes that we could integrate into our program. Similarly, on policy, policymakers could come and say, here's a potential policy that should be considered in the trade space. Here we're talking about, again, a partnership program to develop a solar thermal OTV, where you would see the NASA and Space Force putting in a fair amount of money for first unit and access, SpaceX helping develop with some of their own funding so that they could produce additional units down the road, and our European and Canadian allies helping out so that they would have transport rights for their own astronauts to the lunar base that this OTV would support. I mentioned before the breaking down of the technology taxonomy. So this screen right here allows you to drill down into the details of the taxonomy. So here we've got propulsion systems selected, and then you would select the other propulsion systems, and you'd start seeing some of the very advanced propulsion systems, which is what I do during the day when I'm not playing with oracles. And that once you've picked a particular technology, here again we're looking at solar thermal, we have this visualization of the pathways that would be used to develop a particular technology from a TRL-1 back of the envelope, napkin sketch, to a TRL-7. Hey, it's been demonstrated in space and we're ready to go forward and integrate it into a mission. All these different boxes are basically, what needs to be done to move a particular piece of the technology up one TRL level for one of the different types of solar thermal options and whatnot. And so, we imagine that a fully fleshed out version of this would allow a user to map out their development program for particular technology. Once decisions are made on policy, the user would be able to see how its potential to be actually passed by the appropriate governing body. So here we're kind of modeling the U.S. House and Senate for it, and of course, for other entities, we would have a totally different governmental structure, say for China or the governmental structure of a private company. Sorry, I'm going a little fast here, but oh, I think, yeah. Yeah. So one thing I haven't talked about all here, and I'll kind of go back to our breakout, is how budget integrates with all of this. And so we're still kind of working those details out, but we've got budget for the next cycle, the next year after you've made decisions for a year, cycling through where population, economy, and influence feeds back into the budget that you have for the next year, and that budget is being used to fund new technologies, new infrastructure, and new missions. And so in the program, you have this budgetary final screen here that is going to show you what projects you invested in this year, how far you got versus how far you thought you were going to get, because everything is evaluated probabilistically, and then allows you to kind of balance your portfolio, canceling projects and starting new projects, so that you can continue to optimize your development process. So I want to leave a little time for talking and whatnot. So I've kind of covered this. I think it's it's well made that this is a very ambitious project. So all models are wrong, but some are useful. I very much believe that if we end up with answers that are just so wide in scope because we're so uncertain about the data, that in itself is an important answer to be heard. And I'm less concerned about getting an accurate answer the first time out than for this program to and this whole project to be a way to organize all of our thoughts as we discuss all of the different options and work together to figure. So along those lines, getting in there and developing all of these different algorithms that would be needed on the back end to do these calculations. I started sitting down last night and writing a lot of what I'm calling master's theses, where we would probably have an intern just tackle one of these little projects. A lot of these that you see listed here are frankly things that have been covered, at some level, but needs updating, needs to be cleaned up, needs to be, brought into, a predictive methodology that we could put into oracles and whatnot. So, I feel like this is just the tip of the iceberg. There's going to be hundreds of these before they're over. I've also got some engineering master's theses going on as well here. So I think I'm out of time, so I better just, I want to leave time for questions. So I was going to leave this screen up for questions, but I tell you what, I'll leave the economics one up and I'll just shut up and see if we have a little bit of talk time.
Thanks, Dr. Adams. As we've watched this kind of evolve, it's kind of inspiring, right? We only have moments to chat, but I want you to tell us what about the conversation you had with the chief economist of NASA, right? So you and I talked about that, but I would like you to kind of share what he said about the complexity of this system. Yeah, this is a complex system. What did the chief economist of NASA tell you about the scope of this project?
He thought it was so ambitious that it would be hard to quantify, which is kind of what I'm addressing here. But he was very interested in seeing some of these master's theses that we might partner on. And honestly, I think there's I think this is one of those things where you're going to have to start producing results before you're going to win everybody over. And so we're moving down that road.
Yeah, absolutely. So
there's certainly a lot of strong interest on the Space Force side, and there is some interest on the NASA side. I do have some funding on the NASA side. So, and I'm working on more, not to allude too much to what Tim was saying earlier, NASA is very risk adverse.
Absolutely. But let's let's pause and let this sink in for a second. So you've got the chief scientist of US Space Force and the chief economist of NASA both paying attention to this. I refer to this as crystallology, right? This is this is hard to do.
Right.
And it may not even be possible, but just the effort is worth the effort, right?
That's exactly. I think we will get. I think we will get useful results. But I admit the possibility that those results may be so disparate that the useful result is, wow, we have no idea.
Right. Yeah. I think there's more.
It really comes down to how big the error bands are on our predictive methodologies. But you know what? Like I said, if it did nothing but organized, if we had one-stop shop where all of the different options could be seen, right? All of the different infrastructure options, all the different technology options that are being discussed. I would think that there's going to be a lot of value, even if we couldn't say, we couldn't narrow down the options more than the top 900. I think if we eliminate the next 900, that's value, right?
Right.
So we give ourselves, there are definitely orders of value that this thing could produce. Ideally, we would run through this whole thing. We would do this for a couple of years. We'd get lots of input from a lot of different SMEs. We would vet this thing up one side, down the other, and we would run the AI through, and it'd say, oh my gosh, you got to develop peanut butter rockets. That's the way you got to go. It's the thing. Peanut butter is storable, and it gives you a great ISP and blah, blah, blah. And if you develop peanut butter rocket, boom, you are going to populate the solar system in 10 years. That's probably not going to happen, but yeah, so.
Well, Dr. Adams, always a pleasure to have you here. Looking forward to the next update. We are going to shift it over to Jordan to bring on next speaker. Thanks a lot, Rob.
All right, thank you, sir.
Yeah.